Um, and we've topped out, it looks like, at 16 people so far. Oh, no, we got a 17th. We got Connie and Dave showing up. Okay, Connie and Dave, you just got here just in time for us to start the presentation. Oh, we got number 18. Let Kevin in. There we go. Should we let a few more people show up?
Did you introduce the board members yet?
Ah, there you go. So with me tonight are our fellow board members, Ginger Wong there, John Rapsey, and Wayne Schneidman. Also a board member with us is, or board members with us are John Spazzeri and David Young, but they are not seeing them online tonight.
I believe John Spazzeri is online.
Yeah, John Spees.
John Spiz is on,
Ah,
but I don't see
we can
Dave.
make him a co-host. There you go, John.
Spazzeri.
Yeah.
Got multiple Johns tonight, not including Jonathan, who sometimes goes by John. So this can get a little.
Yes. Also, one of our current volunteers is oops. Yeah, so our current volunteer is John Evans. He's just started back up after being away from the group as a volunteer for a while, but he's back. So like I said, so we're looking for people to just help us with managing the group. Okay, so I guess it's soon enough. Jonathan, let me read through your bio here. Okay, there it goes. So Jonathan Hadley is has been a zealous GNU Linux hobbyist for about 20 years and worked professionally as a web and system administrator for about a decade. His article on securing an abandonware router hacking the DI-524 interface was published in the August 2009 edition of 2600. He also developed the first Vim plugin to support Sonic Pi. And you ask, what is Sonic Pi? Well, he's going to talk about that tonight. So Jonathan, take it away. You should be able to share any documents you want to share.
Looks like it. Thank you.
Let us know if you have any problems with that.
Cool. I appreciate it. First things first, I believe that this should work. I'm just going to test it real quick. Let me know if you hear a sound that's not my voice and not street noise. Did you hear something like a plucking?
Yes.
Excellent. Cool. That means that my sound is working as I intended to, which is great. Okay. Yeah. Hi, everybody. Thanks for having me back. This is going to be a really informal, loose, extemporaneous, casual presentation of Sonic Pi. It's been a toy and a tool that I've been involved in for a number of years now. I am a musician, sometimes serious and sometimes not at all serious. And yeah, I stumbled upon this and I really enjoyed it. I will first offer the big view, some history, some about the community and the offerings, and then I will get to the fun So I will start sharing my screen here. All right. So first and foremost, as I suspect most people know, music is organized sound, which historically has been done by manipulating the airwaves with wood. You can percuss it, you can make it vibrate, string, brass, any number of methods. And as we started experimenting with electricity, we started developing electronic music. You know, it was first adopted in kind of classical settings and became very popular in popular music. And with the advent of computers, especially accessible personal computers, digital music became more and more accessible. There's lots of options for that. I mean, heck, I'm pretty sure you could actually just get a BS in home music production. But the piece of software that I will point to is Super Collider, which is one of a number of general purpose audio synthesis platforms. I'll just read the first sentence up here. Super Collider is a platform for audio synthesis and algorithmic composition used by musicians, artists, and researchers working with sound. It's free and open source software available for Windows, Mac OS, and Linux. So one of the reasons I bring up Super Collider right now is because that's actually the back end and the heart of Sonic Pi. Sonic Pi is a digital music synthesis platform, which was designed really to make music accessible to programmers, but also programming accessible to musicians. So it, at least ideally, I'll just pull that up right away. Ideally, is an education platform accessible to kids and adults, but under the hood, because it has this powerful platform behind it, you can do real heavy work with it as well. So it can be just a fun toy, but you can make some really cool and interesting things as well. So Super Collider originally was its own, C or Pascal derived language, which only made sense if you had some working knowledge of low-end audio synthesis and coding. And they eventually opened up their API to make it accessible from other languages. And the first effort made, or one of the efforts made, was from this fellow Sam Aaron. He is a professor at the University of Cambridge, and therefore has a big interest in music and programming as a tool for education. And his first big effort was Overtone. Overtone is a front end for Super Collider written in Clojure, which is the Lisp-like functional programming languages built on the Java runtime engine. It's a lot of fun, really interesting, but not everyone knows a lot of Clojure. So after experimenting there quite a bit, he went on to make Sonic Pi, which is Ruby-based and specifically designed to work on the Raspberry Pi. So it's accessible both in terms of an easy way to come into it with the programming language, but also accessible because all you need is a Raspberry Pi, which is a much lower barrier of entry than even a low-end computer. And one of the cool things about that too is it really doesn't require all that much power. In fact, one of my favorite synthesizers ended up being too powerful for the Raspberry Pi and they dropped it. But because there's the advanced backend, I was able to continue using it just privately. So that's kind of the boring history. I will say too, I will bring us to the usual user interface, but I will mention briefly that there is an Emacs plugin. Every now and then I think that I'm going to try Emacs and I give up after a few months, but it's a perfectly usable plugin. And because I always return to Vim, I ended up making my own plugin, Sonic Pi, which, all right, it's up to 101 stars, which I'm really happy about. So if you decide that this is something you want to experiment with a lot more deeply, and you prefer either Emacs or Vim, you can look at these plugins and work a lot more comfortably. And I'll mention too that my plugin, don't maintain it that well anymore. I'm hearing some noise. Oh, now it's gone. All right. I don't maintain it that well anymore, but someone forked it, and I've linked that from mine. So Vim Sonic Pi by Lily and Starlight. I've experimented with it. It's great. So yeah, feel free to play with it. So I will stop sharing this and move on to Sonic Pi. Any questions as I transition? Cool. All right, I'm planning on, yeah, just kind of breezing through things, kind of building from small pieces. And it's a full-fledged environment, so it's going to be a little bit tutorial, but mostly just kind of a taste of what's available. So if it piques your interest, you know, I'm happy to answer questions about it, or you can just go ahead and play. So this is the primary interface. Can everyone see that pretty okay? All right, not hearing any objections, I'll assume that's all good. The original coders, probably because of the Lisp background, this is sort of a little bit of an Emacsy interface. It's not Emacs per se, but like the shortcuts feel a lot more Emacsy than Vim. So it's Control N and P to go up and down, Control F, B. You can use the arrow buttons, of course, and then Control E, Control A, etc. But yeah, we will start simple. What do I want to clear out? I will clear out this one. All right. So easy as pie. Let's play C. I type that in, play C, perfectly natural. I'll hit Alt R to have it run. And yeah, there it is, a C. Now that we've got that started, I will mention a bit more of the interface. Up here, we have an oscilloscope. Everything can be turned off or on. I'm just going to leave it on for now. Down here is the log that lets us know what's going on. It's starting a run of my play. Completed that run, all runs completed, pausing the Super Collider audio server. So I'll run it again. Starting run, there we go, it did it. So that's helpful for finding out what's going on. You can also, do a puts to write directly to the log if you need. And you can see here, there's that high there. So that can be helpful for troubleshooting, or if you want to do other fun things. It's an advanced topic and nothing I've ever played with, but you can also use this to interface with MIDI or OSC. And I forget what OSC stands for, but it's kind of like the modern hip version of MIDI, which would allow you to interface with other controllers, be they keyboards, external synthesizers, lighting equipment. There's even, I think, an externalization that you can combine this with Minecraft if you wanted to play around with that. So yeah, lots of fun things you can do. So C is also C4, is also the MIDI note 60, and it just understands all of those things. Now we can also give it a list, and here we have a major chord. Now, if we want to play things in sequence, we have a number of options. The first thing I'll kind of show you is sleep, which probably makes sense in the greater scheme of things. Sleep 1. Now, 1 is the duration of 1 quarter note. If you understand music, you know what that means. If you don't, just trust me for now. It's essentially how many beats you have, like, and of course it's contextual. Once you get into more advanced music theory, that can vary. But for now, we'll just say it's a beat. So we'll go up the scale a little bit. Now, that's understandable, simple enough, straightforward, but of course not very pragmatic. So a shortcut we can do is play pattern. And you'll notice too, I should have asked this to begin with. Is this size okay? Can you see things pretty comfortably? Can't hear you, Scott.
Yes.
Yes,
Cool. Excellent, cool.
especially
Now-
the side by side mode works very well.
Sweet. Cool. Thank you very much. All right. So, yeah, you'll notice that the UI has these drop downs. It kind of anticipates what you're going to do. I have that in my Vim plugin. If I remember correctly, Emacs has that as well. So it makes it really easy to kind of discover things. Like once you know the basics, you can just start playing and experimenting. So we know that play will play a note, play pattern. Let's have a look at that. C, D, E, and we'll just go up to G to make it sound a bit more natural. So that plays a pattern for us. And if we want to have a bit more control, oh, that's how it goes. So by default, if you're doing a played pattern, it'll just do one beat, like that sleep one we were doing before. And that's the default. Oh, it expects the normal behavior. So that's the default one. But if we wanted to elongate it, we could say, play it for 2. Or we could mix it up. So we'll do a quarter note, a half note, a whole note, or rather a quarter, sorry. We will do a 16th note, an 8th note, a quarter note, and a whole note. And so there, even if the whole idea of like quarter notes, whole notes, even if that's kind of foreign to you, you can see that there's a mathematical correlation here. So you can play with it and just kind of get a sense of what's going on. Yeah, that's the basic play pattern. So the big question or piece of it here is what gets played. And the short answer there is a synthesizer. So use synth. And here we can see in the dropdown a number of synths, actually quite a few. And the one that's actually being played, the default synth, is this top one, bell. I'm sorry, beep. So let's try a different one. Let's go with D pulse for dynamic pulse. Quite a bit more synthy. Let's go with FM, frequency modulation. Much deeper sound. So with this, you can begin experimenting, or you can write melodies alone and then just play around with the synths. Additionally, I'm going to comment that out. You can also just say synth. Synth, we'll go with D saw. And then note C. So if you're familiar at all with Ruby syntax, this becomes familiar. The first argument is D saw. And then it's been a while since I've used these terms. The option, note, you need to define, and that can be 60 or the symbol C4, whatever it happens to be. Then in addition to that, there's all these other options. Amp for amplification, attack level, cutoff, decay. If you're already familiar with electronic music, these terms should be familiar to you. But if this is new, you can begin to play. If there's interest, I might explain some of it for now, but I'll start simple. These options are available. So yeah. Or again, you could just put that as play 60 and replace this up here. Okay, so that's basic synth. I'll mention two. Let's just do play pattern timed. We'll do C major again. Oh yeah. So the default C is C4. So we'll make this C5 to go up the octave. So we've already established that we can use different synths. While we're doing that, we can also use different defaults. So here, let's go with cutoff 800. I'm just making this up. I probably should have planned ahead of time. All right, that's not a thing I can do apparently. Let's go with amp. I know that amp's a thing. So amp is amplitude for how loud it is. So let's compare that to this. So hopefully that volume difference is legible through Zoom. But with this, you can start separating out these notions, keeping them a bit separate so you can play with them. And once we get into looped patterns, where you might make small incremental adjustments in time, it's nice to have these things separated, and we'll get there soon. So this is kind of the first step, the building blocks, with the synthsar, playing in the patterns. I'll also mention there is chord. We already touched on that with simple lists, but we can also do chord C major. And if we wanted to do, say, minor 7, that's available to us. And with this, we could experiment and play. Lots and lots of options there. Bless you. We also have the sample function. And if you're familiar at all with electronic music, this should make sense right away. But in short, it's a recording. And a recording we can play with. So just like with the synthesizers, there's lots and lots of pre-built options. But I'll mention too that we can bring in our own. So I'll just sort of start with, we'll go with this loop. I don't even know what this is. Let's just hear it. Cool, that's kind of neat. So we can play with that. We already mentioned amplitude, so I'll turn that up a little bit. I'll restore that because I think it's probably loud enough. One of the cool things about samples is we can play with when they start and when they end. So the way that works is it's sort of like a percentage between 0 and 1. So we'll do start. We'll start halfway. And just to hear that again, this is the whole thing. Starting halfway. Just the end there. So start at a quarter in. So with this, we can start having some fun. Let's actually start it a quarter of the way through and end it. Is it finish? Yeah, finish. Halfway through. So yeah, we can play and experiment with that. I believe we can also reverse it. Let's see. Oh yeah, beat stretch it. So we'll do that one. Let's make it long. So what this is doing is it's taking the sample and basically making it 16 times longer. So I'm going to stop it real quick. I believe, let me confirm. Okay, so this does work in actual seconds. It's been a while since I've done that. So I don't remember exactly how long. Actually, can I check that? Sample length? Duration, here we are, sample duration. Let's see, that's loop. me hack it too, I think. Oh, okay, puts sample duration. Here we are. So it looks like the sample duration is 2.47 seconds. So let's put that to the test. Sample loop me hack it to beat stretch 2.47. Should sound approximately the same. Yep, approximately. Cool. So if we kind of double that to 5, it should be about half the speed. Yeah, and it sounds pretty natural. A lot of the times when we're stretching digital files, there's a lot of artifacts, and the algorithms they use for this I like quite a lot. It feels pretty natural to me, at least. So yeah, these are things we can do, we can play with. I know that there's a way to put that backwards, but I can't think of it right now. So I apologize for that. Oh yeah, there's a help dialog. So right here, we can look at info, not info, what is it, help. Which brings it up down here. We can also separate it into its own window. But I'm just gonna look at lang real quick. Let's see if I can find anything for reverse. Doesn't look like it. I'm sure there's a way, but I apologize that I've forgotten it. But this is handy when you know that you want something and it's there. It also has a tutorial examples. I'll probably hit some of those. Synths and all of their details. FX, which we'll go into next. A variety of effects that we can play with. And then the samples that are available and what kind they are. Ambient sounds, drum sounds, the me hack it sounds. So let's stick with me hack it for now, and I'll demonstrate some effects. So sample loop me hack it too, because we're familiar with that. With effects. Some of these should be familiar, or these just make sense. I mean, I guess depending on how familiar you are with things. But we'll do a simple reverb. I think it should be accessible to most people. Yeah, here we are. Ruby has these clauses, closures, I think they're called, where you can define what you're doing with it, hit do, loop it in an end, and yeah, we'll just see how this reverb sounds different. Might not have been so clear. Let's check the mix on that. Okay, so the mix allows me to put more of the reverb on. I believe it's 0.5 by default. Yeah, so 0 means effectively no reverb at all. And part of the reason we might choose to do that is to begin changing the dynamics as we move along, or just experimenting. That's one of the things I really love about this tool, is simply experimenting. I've got a musical idea, I can quickly hack it out and change variables. So we'll keep this at, say, maybe 75. Yeah, cool. Another effects is that usually I can tell a lot about. We'll go with crush, which is like a bit crush. It'll make it sound like a much lower quality digital sample. And resolution, I think. Nope. Okay, so this might be worth noting. Down here at the bottom where I get the error, it tells me a little bit about the error. And the res value must be less than 1. So let me just try. Let's go with 0.25. All right, I believe that's resolution, but I'm not 100% sure. So I'll just look it up real quick. FX, crush. What is res? Oh, that's resonance, filter resonance. Okay, that's harder to explain and describe. So we'll just ignore resonance for now. Sorry about that. Yeah, we'll just keep that one. I will do low pass filter real quick. A low pass filter basically cuts off the top end of the sound and leaves the bottom end. So in terms of effects, if we're hearing something like, say, through a wall, typically we'll only hear those lower frequencies. So as effects, like say in film or in a podcast or an audio story, if we put something with a low pass filter on it, it might sound like it's further away or deeper or yeah, through things. So all right, and here I know that we can do a cutoff. Let's try 800, and we'll ignore that stuff for now. What am I doing wrong? Oh, okay. So this is okay. It's either new or I've just forgotten it. Where the maximum value is 131. So we will do say 40. See how that sounds. Okay. Over here in the oscilloscope, we can see that things are happening, but it's just really too low for me. So that's not a very helpful value. Let's try 80. Yeah, so that's a bit more audible. And we can just experiment. So cool. Those are samples, those are effects. Those are the primary building blocks for making sound. And so far, like we did with the sleep, everything else, all of this is kind of procedural, step by step by step, which is fun when you're just experimenting. But when you want to start putting things together, you want a loop. So we'll do live loop, play around, do, end. And what this does is it creates its own thread so that we can have multiple live loops playing at the same time, independent of each other, and make different experiments. So let's start simply by playing C once every beat. So I'm going to change the value. Now notice I've changed the value, but it's still playing C. It's because I still need to run it. That is to say, I still need to take this data and send it to the server. Once that's done, it'll update the value. So I'm going to do that now. Bring it up to E. Up to G. And I'll stop it before it gets too annoying. But yeah, with that, you can kind of see the options available. So I'm going to start, maybe trying to make a simple beat. Oh, that's the other thing. I'll start with the beat here. So sample BD for bass drum. Let's go with, Me Hackett's been pretty cool so far. That's kind of neat. Yeah, I don't really like that too much. So let's actually do something else. BD house. Yeah, simple enough. Let's see. Here we are. Pitch. Let's raise it a little bit. Can I do? Okay. Equal, less than or equal to 24. So that's my metric. So let's go with. That's kind of cool. So let's add another drum to this. Whoops. Let's go with cymbal pedal. Doesn't sound very good. Yeah, that may not work, but you can kind of see what I'm playing around with, an experiment. One thing I'll mention that I didn't think to mention before, I think I don't know if you noticed it, but I definitely felt a delay when I first did that symbol. Uh, this can call up the samples like on the fly, but it takes time for the IO. So if you're kind of in a mission critical situation, you can preload those samples. So I'm going to actually skip ahead to this here, which is something Sam Aaron, the guy who first started writing Sonic Pi, wrote up. This is his homage to the song Blue Monday by New Order. The band Orgy covered it in the 90s. So I'm going to walk through this real quick so I don't bore you with me experimenting. Use debug false, so no debug stuff, and then he preloads the samples. So here's this first live loop. He labels it 6 times for this drummy, this drum heavy kick at a decreased rate, and then sleep for half a beat. And then he has these fast drums, same heavy kick, just like that. So I'll just demonstrate that real quick. I know too, I'll just point out that because this is kind of a prearranged thing, he has a second live loop with a delay. So that this first loop will play all on its own to begin with, and then the second loop will come in, then later on this third loop will come in. And so for now, I'll just play this first loop for a little bit, and when I'm ready to move to the second, I'll show that to you. So here we go. Slow drums. All right, so we already jumped into the synths there. And here, we see use synth uses a modulated saw. The saw describes the waveform. It's kind of like a saw shape. And the defaults are at half volume, attack 0, meaning it attacks right away. Sustain 1, it lasts for a single beat. The release lasts for a quarter of a beat. I'll ignore the mod range stuff for now, because that probably doesn't make too much sense unless you have some experience with that. But I will point out this ring business. You'll remember I showed you the chord function. That uses rings. Rings are essentially just lists that allow you to iterate over them repeatedly. In Ruby, by default, there's not really a comfortable way of doing that. I know that like Python can do that really comfortably. This gives that functionality. So Sam Aaron establishes this ring of F, C, D, D, G, C, D, D, and then he iterates over it each. Now this tick means wait until the next loop iteration. That way, if you rerun this, it's going to stay in time each time. And then play the note N. So we'll say like this first time it'll be F in the first octave with these cutoffs. Now, this is a little bit of an advanced option, but I'll point it out to show you what's available. And this is line 90 to 130, steps 16. So that's effectively creating a line vector between 90 and 30 that takes 16 steps. And that allows you to effectively change that value over time. And that'll return an object with the look command, which allows you to basically to set that cutoff variable without affecting the underlying item. And then the second note is very much the same, but a little bit different. Same note, second octave, and the cutoff uses the same line, but with more steps. So it'll move a bit more quickly. Kind of a high concept thing if this isn't already familiar. But once we start playing the synths, let me comment this out so that we're only listening to the synths to start with. From Vim, I know how to do this quickly, but not you. Yeah, we'll just see how that sounds. changes. So, it might be too subtle for Zoom to hear those differences. But this also kind of demonstrates changing things live. Because, let's see, we'll go with beat. Because of this tick, it makes sure that any changes I make don't take effect until the next loop. So, loop just started, I'm registering it, but it won't take effect until now. Oh, not now. Now. Because it's a loop of 1, 2, 3, 8 notes, so therefore 8 kind of measures. All right, and just to have a little bit more variety, I'll bring these back in. And to restore the original sound. Yeah, they really dig that, or you're glad I made it stop. So thanks for bearing with me there. That's kind of the gist of it. I'll mention 1 or 2 more things real quick. Well, I guess here I'll just point out, I didn't finish the pattern. And again, this makes mathematical sense, and if you're a musician, you kind of get it. Because a beat is a single integer, you can do thirds with 6 6 and 3 3. So yeah, and maybe a minorly advanced feature. I might not show all of it, or maybe I will, just to so I'm kind of proud of it. So I mentioned earlier that there was a synthesizer that I really liked that turned out to be too much for the Raspberry Pi, so they dropped it because they wanted to make sure that the Sonic Pi always fit Raspberry Pi, and that's this dark C horn. But I loved that voice so much that I retained it, and I compiled it on my own and decided I can load it up here. So the load synths defs is a more advanced command where I can just send it to where I have that compiled here at Sonic Pi synth defs compiled, enable use external synths, and then I can start to play with it here. As a brief explanation of what I've got, most of this should, kind of make sense. So, oh, I didn't mention that. You can set your own definitions. Since this is Ruby code, I basically just set a function for intro. And this way, I've got my horn defined. I can set a default root and therefore change it if I decide I want to change keys. So this is a C4 by default, but if I decided later on, you know what, I'd rather this be an E, I don't have to go and change E everywhere. I just change how I call it. So this first effects is distortion with its details. And I will mention briefly this Rubyism where you can send a yield value. Okay, so this might be worth mentioning, yeah. I can send this yield value, in this case distortion, and here GV, which in my head was GNU verb. I think they've actually got a separate algorithm now, but I still have that as GNU verb. And by yielding that over into this, we can make those changes. So here's this first one, synth horn, which is defined here in the beginning of the definition. Note root, sustain it for 20 beats, release as 80 beats, and it's at half volume, sleep 1. Next note, root -7, which is, if I remember correctly, F in this instance. So it's 7 half steps down from wherever the root note is, sustain for 19, release 7, half volume, etc., etc. I make these changes here. And then this is where some of the advanced stuff comes in. I call this synth with an equals, and that gives me the freedom to control it. So it's a horn again, root 2 octaves up, and I'm sorry, an octave up, an octave plus 2 up, sorry, higher sustain, etc. And then I sleep for 4, and I hit control, and I can change the values on the fly. And that allows for what in music we call portamento, different legato things. I will demonstrate this in a moment. Without all of this, I'll just on its own, because I have, here we are. I have that identified alone as this motif, where I have pretty much the same settings. I call that note sleep for 3. I control it to raise it not quite a full step. So it's flatter than it sounds like it should be. That's intentional on my part to make it sound kind of spooky and scary. And then I bring it down. And because of the distortion and the reverb, it has this creepy effect. So let me play that real quick. Here we go. And to me, in context especially, that can be a really haunting thing. And if you'll indulge me, I'll play that intro with all of the notes. I've tried it before and it doesn't sound that good through Zoom. So yeah, please be gracious about it. Yeah, so that I actually used in a theatrical production. I was able to do sound design for a show, and that was my opening piece. So, again, it doesn't sound great over Zoom, but I'm pretty proud of it, and I was able to use that in an actual production. So, yeah, you can do fun little play things like Daisy, and you can do kind of grandiose experimental things as well. So yeah, I think that's really the gist of it. Thank you for listening in, for being with me as I explore this. I'm happy to answer any questions. Yeah, I hope that was good for people.
I just want to mention, I put in the chat, excuse me. Sonic Pi is available in the software repository in Linux Mint. I haven't loaded it up yet, but it is there, believe it or not. Just thought I'd mention that.
Cool, thank you. I didn't look at the chat at all during my talk, so I apologize when I was soft. It will go to 11, depending on your hardware.
So you were running that on a Raspberry Pi?
No, I was running that on my home computer here.
Okay.
But in theory, everything except that last bit that I did should run on a Raspberry Pi.
What are you running as what operating system?
I'm running Arch Linux.
Oh, so this is in Linux. So it's probably in the software repository for every distribution, I bet.
Yeah, I don't remember if this is let's see, like Arch is odd, so I might have just nabbed it somewhere. But yes, Arch has it. It's reasonably popular.
Well, Linux Mint is Debian based, actually based on Ubuntu.
Yeah, definitely. I see a question here. What is the meaning of note 60? And I probably mentioned that quickly. I'm sorry that it wasn't clear. That's MIDI note 60. So there are 88 keys on a piano, and that's basically the 60th note. You can actually tell it. You can actually set things in hertz. You need to use a special function because humans don't normally think that way. But you can actually do that. You can send it, I think it's just HZ, whatever hertz you want, and it'll convert it into whatever its internal system is. But yes, when I was writing 60, that was MIDI note 60, which is the middle C. And in most contexts, it can either understand the symbol for the musical note or the MIDI note. And in those instances, it just came more naturally for what I was doing. I see the question in chat, can the mix parameter go so far as to generate feedback? By default, no, but I think you can always find a way to break things. Yeah, because again, like, because this is sort of designed as a teaching tool, you know, it tries to, you know, give you some sane defaults, but it does allow you to kind of get under the hood and do more advanced things, break those safety nets. So if that's something you wanted, you could. You can change bass, like system mixers, like, yeah, you can run wild with it. By default, though, it's intended to be kind of sane, so you're not blowing out your ears.
So is the development moving forward on it at a reasonable clip? Because I looked at this several years ago, and there were some disappointing features like no automatic amplitude compensation. Like when you send, if you were just sending it to speakers, the low notes would just disappear because you have to do like an RIAA amplitude compensation to get the low notes amplitude up so that they generate the same acoustic level, right? And so when you were writing code, you had to actually, you know, play with the amplitude all the time, you know, and basically you had to do that kind of manually. But it seemed, the presentation you did, I didn't see any of that. It seemed like, you know, the normal acoustic levels were pretty flat all the way across. So maybe that's something they fixed, or is that something you fixed, or were you ever aware of it?
I don't recall whether or not I'd been aware of it. I will mention that that more advanced piece I did at the end, when I first experimented with it, I felt like it was kind of overblown. So I did set the amplitude lower to kind of compensate. I will say that it is an active development. I updated this a couple of weeks ago. Despite the fact that I use Arch, I'm usually kind of lazy about updating things regularly. And since I updated this a few weeks ago, there's been a new version out. So I know it's under active development. Whether or not that is, you know, quote, fixed, I'm not sure if I could say, but things sounded good to you today.
Yeah, I mean, I didn't notice you having any drop-offs, you know, like on the low end. So they must have done something, or I guess it's possible you might. I mean, you have a sound system on your Linux box that you're running it through, or
not for this presentation. I'm just using my onboard sound. Yeah, I do have an external interface, but yeah, I wasn't using it today. So I'm guessing they did sort of fix that, but again, they will let more advanced users like us fiddle. So it might be that even if it's not behaving as you'd like, that you may have access to that so that you can set something that's a bit more automatic.
Cool.
So you should read up on the latest notes.
Yes, agreed. And I'll say too that I've found it's been a while since I've really played around, but I found the user community to be pretty good because everyone's just kind of excited about it. And at least as of, gosh, when I first wrote that Vim plugin, there was probably like a couple of dozen people that seemed to be online and active all the time. So Seems to be a reasonably close-knit group too. At least it was a few years ago.
Just an interesting note that the Sonic Pi comes pre-installed. If you do have a Raspberry Pi and you do the full distribution download for, it's now called Raspberry Pi OS, that it's included in there. So you just have to boot it and you can play with it. So it's
Cool.
kind of neat.
Yeah, totally.
That sounds good.
Yeah, I think it's a neat little thing. I've just never actually picked up the Raspberry Pi, and I'm glad it works in all systems.
Okay.
Oh, well, so you said you didn't run it on the Pi, so this question is probably moot on you. Then it's like, do they have a plugin that allows you to connect it to the GPIO pins somehow?
I don't know, I'm afraid.
So like you could actually invent an instrument and run it through Sonic Pi somehow?
I couldn't tell you. I do know that it supports MIDI, so if you do an instrument through MIDI, that'll work. But I don't know exactly.
Okay. Any other issues, questions,
Hey Scott,
ideas?
your mic is overdriving really hard.
Let me try doing something about that right now. Better?
Much better.
Sorry about that. Like I was saying, so questions, issues, ideas for Jonathan? If
That's
not,
a great presentation. It's great. It's a fun tool to play with. And I
it's
used to
been a
refer
while
to it
since
as
we've had some sort of musical
yeah.
type presentation. So it was a good idea, Jonathan.
I used to refer to it as where Ruby hides on the Raspberry Pi. Because and the funny thing, you go through the tutorials, I don't remember it ever saying in there that this is the Ruby language. I don't think it ever said that. I sort of kind of stumbled onto it. I think it was like when the like you had a command, the 6.times. That's when a bell went off. This is probably Ruby, but I don't remember them actually saying this is Ruby code. And then once I figured that out, I was like, yeah, you can write loops. You can do anything you do in Ruby. You can wrap stuff up in it. So it's pretty cool. Fun toy.
Yeah, totally. And thank you. Yeah, I mean, I don't remember. Yeah, I guess they don't say it so explicitly. But it is sort of like a domain-specific language, but it's all Ruby behind it. So
Yeah. That's kind of a cool thing about Ruby, though, is it's so plastic. You can twist that language into looking like something completely different. I mean, what they've done is kind of almost makes it look like it could be a bash script. There's an occasional comma that has to be there, but a lot of times you're like, you could be fooled into thinking it was a bash script. So.
yeah, absolutely.
Okay. Okay. Anybody other than Ron want to comment? Or does Ron have more things? He's doing good so far.
I think I'm okay. Just real excited to see that people are actually playing with that and are using it, and it seems like it's gotten more professional. So it's very exciting.
Yeah, me too. I'm glad to share it.
Okay. Anything else? Anybody? If not, we could thank Jonathan for his presentation on, like Ron was saying, this is a good presentation. Thank you.
Thank you.
Okay, and as usual, our speakers are invited to our pizza party, which we hope to have at in December this year. I believe we're if we have any speakers from last year that we didn't invite to our non-pizza party last year because we were afraid of infecting anybody. We are planning on inviting those 2020 speakers to our 2021 pizza party. So please come to us with any new presentations or ideas for presentations. You get the pizza, free pizza for being somebody who does the presentations, not for coming up with the ideas, but we do appreciate people coming up with the ideas on topics or other people that are the presenters that you saw someplace else and think, hey, they would be good for Uniform Chicago. So, hey, Wayne, had we heard anything from the library yet about what they're planning for in library meetings in 2021 yet?
Nothing new yet. I think we can get a room with, I don't know, something like 16 people maximum and all spaced out. If they have one room available for that and only at certain times. So it doesn't look promising.
Okay, so they haven't given any feedback on anybody taking them up on that offer
No,
yet?
no.
Okay, so we'll probably have to wait for the Department of Health's feedback on how they think the virus is going before we can go further into being in person again. Yes, and yes, we are going to try to have a hybrid meeting where we have some people in person, some people still coming in through Zoom, but we haven't figured out how to do that. So the first time we do it, it will be a test for everybody involved. So there's something to think forward to when we start getting back into in-person presentations again. Does anybody else have anything they want to provide? I'm sure Jonathan could do with some more positive responses to anybody, from anybody. But it looks like he's smiling enough for the whole thing. Good.
Presentation was really good, and someone posted a link in the chat. If you go there, you can actually download a version for the Mac too.
Oh, okay.
Probably
So
Windows if people still use that.
excellent. Okay, so usually what we have for our in-person meetings is we go off to a restaurant and sit there and chat more about anything that anybody wants to come up with. But since restaurants aren't letting us just go in by ourselves anymore, and everybody being at home, it's not been something we've been doing recently, but we're looking forward to that too once we have in-person presentations again. But meanwhile, we've been doing just chats after our meetings. We have plenty of time on the Zoom call yet to go before they would cut us off. So we'll do that for a little while. So if anybody just has a topic they want to bring up, we'll go on to that. Thank you again, Jonathan.
Yeah, thank you. You're welcome.
Okay, and we had a maximum of 23 people show up tonight.
So if there's a general interest in Raspberry Pis, I have it's about a 20-30 minute talk on accessing the GPIO via Python on a Raspberry Pi. If that would be of interest, I'll get in touch with you, Scott.
Okay.
Maybe
Yeah, send something, if you got something written up, send it to info@uniformchicago.org. And we'll
Did
continue.
somebody type that in the
conversation.
chat already?
info@uniform, UNIFORUM, Chicago.org.
I'll just type it in there so I can save it.
Yeah.
Does that look good? Uniform Chicago.
Let me see. Yes, it looks right.
So possibly you have one in May, right? So third or fourth Tuesday of the month.
We usually like to have our meetings on the fourth
Fourth
week of
Tuesday.
the month, and usually we've been doing it on Tuesdays, but we've been open, especially with Zoom meetings being we don't have to have a meeting room assigned ahead of time.
Yeah. Fourth Tuesday works good for me.
Yeah.
All right, I will get
Ah.
something to you, and it would be, like I said, it's about not more than 30 minutes. Depends on how many questions there are and stuff.
Okay.
But I did it's basically walk you through a thing on connecting your GPIO to a shift register so that you can expand the pins and stuff. And but it's more an exercise into dealing with the GPIO 0 Python library, which is pretty extensive, so should be interesting.
Okay, so Sid came up that there's a version of Sonic Pi designed for Windows 10. Thank you, Sid.
If I can interject real quick, I noticed Joe Sullivan's note. Is Joe Sullivan? Did I have that right? Yeah. So something I hadn't mentioned is that Sonic Pi uses Jack, the Jack audio control kit, which is either glorious or horrible, depending on your perspective. It's so if you're using it on your desktop, you kind of need to plan ahead. Usually I'll do PA suspender or PA suspend to suspend my Pulse audio and then just start up Jack. But actually what I learned exactly for this presentation is that you can download the Pulse audio Jack sync. So I'm actually running Jack and as like a module to, I'm running Pulse audio as a module to Jack, which has enabled me to run Jack, Sonic Pi, and run Zoom and normal Pulse audio. But it's not as complicated as I expected it to be, but it's a bit complicated for here's how to learn Sonic Pi. So I'm sorry to have tripped you up there, Joe. Yeah, that's a caveat.
Well, that's part of the fun of working anything music oriented because you get you involved in the audio stuff.
Definitely, definitely.
Okay, so all right, so we'll if there's any other topics someone wants to bring up, like for example, I'm assuming everybody's had a chance to get vaccinated. I hope everybody is taking advantage of that just to help us get towards, like I said, getting the library open to having full-blown in-person meetings. That's probably the way that the county will feel much better about having the libraries do that. Let's see. Hope everybody had a chance to go outside today, because it was starting to act more and more springish with it being really warm during the day and it still 40 at night, 40-ish at night. So, but it's definitely starting to act more and more later in the spring. So. Okay. So board members, anybody else got something we should be talking about? There we go. Ron came up with another thing. He pruned his apple tree. That'll be good for later in the year. All right. So Wayne,
Yeah.
Ginger, both Johns. or 3 Johns. If there's nothing else that anybody wants to talk about, take advantage of having a group of techies.
Okay, I'll ask.
Okay, well, thank you, Sid.
I can ask one. My notebook has a gigabit Ethernet port, but for some reason it won't go above 100.
Then isn't that by definition not a gigabit Ethernet port?
That's the question. The hardware and the driver says it supports gigabit. However, speed test says it doesn't.
Do you have something to directly support that speed? Because if everything you have is only 100 megabits or whatever.
Let me give the easy version here. I'm going directly into the Comcast cable modem with a Cat7 cable. I have a dongle version, gigabit Ethernet. Plugging it into the same notebook gives gigabit speed. Plugging it into the Ethernet port on the notebook is only giving 100 megabit speed.
Then it sounds like you said it's either the driver or the hardware itself really isn't able to support the higher speed.
That's the question.
Yeah, and I'm not. Can anybody else think of something else other than a driver or the hardware? Ethernet hardware, or it's the same cable.
Same cable.
Okay, like I
same
said, so
port.
that's the one other thing that could be different and cause problems. But if the same cable works well with the dongle, but the Ethernet Ethernet plug for the Ethernet cable doesn't want to work, then I don't know.
I was just wondering if there's perhaps another driver to try. It's a Realtek chipset, if that makes any difference.
Which operating system are you trying to use?
It's Windows 10.
What?
Windows 10.
Oh, okay.
Well,
Did you do a nice Google search looking for problems with using gigabit port for my Windows 10?
Yeah. Tried rolling back driver. That didn't make a difference. Went into advanced settings and locked it to what it says is gigabit. You can select 10100 or you can select gigabit and lock it at gigabit, and it's still giving 100 megabit speed.
Then sounds like you are listing all the possible, things to be looking at. The only other thing I can think of, no, that doesn't make sense. Now with what you're talking about. So.
It's one of those wonderful, annoying in life things that sometimes there's no good answer. It's like my ThinkPad. I have the X1 tablet, and the camera doesn't work. And Lenovo can't even figure out why the camera doesn't work, because the camera was fine until the latest Windows update. Latest being 4 back, because this has been this way for about a year and a half now. But Lenovo can't figure out why.
Yeah. So I have heard about camera issues with the latest Windows 10 upgrade or whatever. So I've heard about that part. I hadn't heard anything about driver issues or things not working as well in Windows 10 for other things like your Ethernet port. So
yeah, it's weird.
I can tell you, someone else has told me about something like that.
Yeah. It's weird. The easy workaround solution is I just plug a different cam in via USB and it's fine. But as I said, not even Lenovo can figure out why the camera itself stopped working and isn't working. Their answer was, well, it must then be the hardware. And I said it's out of warranty. And they said that'll be about $300. And I said I can plug in a nice USB camera for less than that.
Okay, well, all right. Well,
You
hopefully you'll
could,
be able to figure that out, Sid.
If you want to eliminate Windows as the problem, you just live boot a Linux on it if you can, and see if the gigabit speed comes up under that.
There you go.
That's a good thought. I like that. Thanks, Ron. It's a good thought. I used to have a bootable Puppy. In the old days, I loved playing with Puppy Linux, and so I may even still have one around.
Okay. If someone else doesn't have some topic they want to bring up and throw it out to the crowd and see what happens. If not, then Sid, thank you very much for bringing us something different to talk about. And hey, we are an open systems group. We talk about Windows 10. All right, everybody. Good night. We'll see about getting something else for the May general presentation. If you have ideas, like we said, email something to info@uniformchicago.org, which is then put into the chat, so you can go look in the chat, save off the chat before you leave, and we'll go from there. And hope everybody has a good May. Take care, everybody.
Thanks a lot.
Yeah, thank you. Cheers.